In this video, we're going to talk about visualizing angles in radians. Before I turn to this lesson, make sure you're comfortable with what is a radian and then converting between radians and degrees. Alright, so let's briefly recall that the XY plane is broken up into 4 zones called quadrants. So I have my Y-axis, I have my X-axis, we have quadrant 1 here, 2, 3, and 4. Alright, so we have our 4 quadrants, and knowing which quadrant an angle is in is useful because our X values are negative here, X and Y are negative here, Y is negative here. So it kind of helps you with negative signs when you know the quadrant of your angle. Alright, when we're first kind of starting out with radians, you're going to be so like, I don't want to do anything with radians, so just convert everything back to degrees, and that's fine, but we're just kind of going to avoid that step because if you're doing that for every single question for the rest of your math career, that's going to waste a lot of time. We're just going to kind of build up our tolerance of working with radians, so you don't feel the need to convert every single time. But for right now, if you're doing that, that's fine. You're kind of figuring out this relationship between the degrees which you're comfortable with and the radians which you aren't as comfortable with. Alright, so we're going to learn, again, more about radians. Alright, so let's think about the quadrants that we have. Alright, in degrees, we knew that we start at 0, we go up to 90, we go to 180, we go to 270, and we end at 360, back to where we started with. What is this going to be in radians? Well, 0 converts to 0. We haven't moved at all, so 0 radians and 0 degrees are actually the same thing. We go up, let's go half circle. 180 degrees, we've learned that's our conversion ratio is pi, and the full circle is 2 pi. Well, half of pi is pi over 2. And if we do 1, 2, 3 90s, we get 3 pi's over 2. All right, so these are our quadrant kind of delineators when we're talking about radians. All right, when we're first starting out, these are like the fractions we'll keep. When we're first starting out, it might be helpful to remember that this is actually just 1 pi. This is 0.5 pi, and this is 1.5 pi. All right, so how's that going to help us? We'll kind of see in a second how we can quickly figure out what quadrant a radian angle is by just knowing these 4 values. All right, so let's determine the quadrant for 5 pi over 4. Let me quickly just draw what we just had. All right, so we have 0 pi, 0.5 pi, 1 pi, 1.5 pi. All right, so let's look at a bunch of different ways you could do this. First, you could convert this to degrees. If you converted this to degrees, you would see this is the same as 225 degrees. And we know because it's between 180 and 270, that's in quadrant 3. All right, so that's going to take a little bit of time because you're doing the conversion from radians to degrees, but it gives you the type of thing you're more comfortable with. All right, so let's see how to do it without converting it. You'll notice that all of my radian kind of delineators have this pi in it. So the kind of pi in our radian measure is a little unimportant. We're more worried about the numbers that go with it. So we're more worried about this 5 over 4. All right, and if we think about 5 over 4, if we were to just put that in a calculator, 5 over 4 is 1.25. So how's that helpful knowing that 5 over 4 is 1.25? Well, we have 1.25 and then a pi after it. If we have 1.25 pi, well, that's bigger than 0.5 pi. That's bigger than 1 pi, but it's not as big as 1.5, right? 1.25 is smaller than 1.5, so that tells me I'm somewhere in here, which is also quadrant 3. So by figuring out the kind of decimal of the fraction part of my radian measure, if I kind of ignore the pi part, then that can quickly tell me what quadrant I'm in. So in this one, I'm quadrant 3. What about 5 pi over 3? Again, I can convert it to degrees. If I convert it to degrees, I'd have to do the conversion process. I'd figure out this is 300 degrees, and that's in quadrant 4. All right, I can do it without converting. If I just look at 5 over 3, 5 over 3 is 1.667 pi. It's the 1.66 part. All right, and we know our quadrants. Where's 1.66 pi is going to end up? What's bigger than 0.5, bigger than 1, bigger than 1.5, but smaller than 2. So it ends up in quadrant 4. I get the same answer without having to do the version. We're just looking at kind of the decimal part of that fraction. All right, one more. All right, this one confuses people a lot because they'll do pi over 6. Because they're just used to seeing two numbers. I remember if there's no number in front of the pi, it's 1. So we get 1 over 6. And 1 divided by 6 is 0.167. All right. So what quadrant is this going to be in? This 0.167 pi is smaller than 0.5 pi, which is kind of our first quadrant. So this tells me this is in quadrant 1. Other way, convert this, you see it's 30 degrees, and 30 degrees is in quadrant 1. All right, so here's one for you to try on your own. All right, figure out the quadrant for 3 pi over 4. I'll show you the answer in 3, 2, 1. All right, and you get quadrant 2, because 3 over 4 is 0.75. And 0.75 pi is going to be bigger than 0.5 pi, which is straight up, and smaller than 1 pi, which is to the left, which puts you in quadrant 2. All right, so what would you do if the angle did not have the pi? You could have 2 radians or something like that. For these, I would just convert it to degrees and do it from there. A little bit simpler. Whenever you have the pi in it, you kind of ignore the pi. If the pi is not there, you have to convert it to degrees and just figure out what the degrees angle would be. All right, so quick example. What would you do if you had 4 radians? Well, 4 radians doesn't really make sense to me because there's no pi, so I'd convert it. This is 180. Oops. You're multiplying this by 180 degrees over pi radians. So your radians cancel, and you get 4 times 180, which is 720, over pi degrees. And then this I would just have to actually put in a calculator. 720 divided by pi is 229.18 degrees. And 229 is bigger than 180, smaller than 270, so I know this is in quadrant 3. And when there's not that pi to ignore in the radian measure, you pretty much just have to convert it to degrees and then do it that way. All right, so quick summary. All right, the dividing lines between the quadrants are half a pi, 1 pi, 1.5 pi, and 2 pi. And when determining the quadrant, when there's that pi there, you kind of just ignore the pi and look at the fraction part and figure out how it compares to these ones. If the pi is not there, then you have to do what we did in that last example and just convert it to degrees.